All right, welcome back. So let's do a couple examples. Okay, so let's start. First example, let's find the equation of the tangent plane to z equals x sine of x plus y at -1, 1, 0. So now one of the things I like to do is I always like to check to make sure that this point is indeed on the surface, okay? So I'm going to check. If I have x equals -1, y equals 1, then I get -1 times the sine of 0. Sine of 0 is 0. That equals 0. That matches with this. We're in good shape. Okay? All right, so let's take our partial derivatives. So, partial of z with respect to x. Okay, I'm just using a different notation. No big deal. So that's going to equal sine x plus y plus x cosine x plus y. Okay. Partial z with respect to y. That's going to equal what? X cosine x plus y. Okay, so we're going to evaluate those at x equals -1, y equals 1. So we're going to get sine of 0 minus cosine of 0. Cosine of 0 is 1. So we're going to get -1. Again, doing the same thing there, we're going to get -1 cosine of 0. So that's going to equal -1. Okay, so now we can plug and chug. Our equation of the tangent plane is z equals -1 times x plus 1, right? Because it's x minus x0, minus 1 times y minus 1 plus 0, because that's the z point at which we're taking it, okay? I'm just going to write that as z equals minus x minus y. Okay? But I wanted to show you guys how I got all that. And that's not right. Sorry about that. Z equals minus x minus 1 minus y plus 1. So actually it was right. I must have known that somehow. I just did it automatically. Okay, let's do another one. Okay. Let's find the linearization for f of xy equals the square root of x plus e to the 4y at 3, 0. Now here, this is actually the linearization equation of the tangent line. They're really just the same thing. It's just different language. Okay, so we're going to find our z first. F of 3, 0 is going to be the square root of 3 plus e to the 0 is 2. Okay, 3e to the 0 is 1, 3 plus 1, 4, square root 2. Okay, now we're going to take the derivatives. Partial f with respect to x is 1 over 2 square roots of x plus e to the 4y. Okay. Plugging in 3 comma 0. This is a nice little trick. We already know this is equal to 2, right? So this, when I plug in 3 zeros, got to be equal to 2. So that's going to equal 1/4. Okay, it's just a little trick to, keep yourself engaged in it. All right. Partial f with respect to y. It's going to again be, that's going to be 4e to the 4y over 2 square roots of x plus e to the 4y. Okay. Move that over here. Plug in 3 comma 0. E to the 0 is 1, so this is going to be 4 over 4. That's just going to be 1. Okay, so now our linearization, okay, is going to be y equals 1/4 x minus 3 plus y minus 0 plus 2. Okay, so this is our f sub x times x minus x0 plus f sub y is 1 times y minus y0 plus z sub 0. Okay, we'll just write this as y equals 1/4 x plus y. 2 minus 3/4 is going to be 5/4. Okay, let's do one more. Okay, we're going to find the equation of the tangent plane. This is for x squared plus y squared plus z squared equals 4 at 1, 1, square root of 2. Okay, so first thing, we're going to have to check that this is actually a point on the surface, right? So we plug 1, 1, square root of 2 in. We get 1, 1, plus 2. So we're going to get 4 on the left side, 4 on the right-hand side. Check. Okay, now in order to find the derivatives, we're going to have to do this via implicit differentiation. Okay, so let's take this expression again. We take the partial with respect to x, and when we do this, we're assuming that z is the dependent variable. Okay, so z is a function of x and y. So when we do the partial with respect to x, y is still an independent variable. So we're going to get 2x derivative with respect of y squared is 0 plus 2z partial of z with respect to x equals 0. Okay, so partial of z with respect to x is going to be negative 1. I'm sorry, negative x over z. Okay, now in this case, at this point, it's going to be negative 1 over square root of 2, because this is x and that is z. Okay. Now, I could do the whole thing again with partial respect to y, but it's going to come out to the same answer. Okay, so partial of z with respect to y equals dot, 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 -1 over square root of 2. Everything exactly the same. Go ahead and give it a try. Okay, so now our tangent line is going to be, I'm sorry, tangent plane. I have a tendency to do that wrong, say that wrong. It's going to be given by z equals -1 over square root of 2, x minus 1, minus -1 over square root of 2, y minus 1, plus square root of 2. So what's going on? Let's sort of see a little picture of what's going on here. Okay, so we've got this sphere. Let's put it here. Okay, now what we're doing, the point is over here. Somewhere about here, let's say. Okay, 1, 1 actually should be, z should be positive. So there's the xy, and it should be up here somewhere. Okay. So now you've got this plane. Oh my gosh, this is going to be a terrible picture. But you've got this sort of plane here. Your x sort of does that. Your y, this is the f sub x, f sub y vectors. Not happy about this at all. Not happy about this at all. On 1 square root of 2. Looks like I've gotten this wrong thing, but I'll have to think about that. If it's something else, I'll make a new video, but it looks like I've put the vector going this way, but I'll have to think about that.